Okay, in this case, we are looking for proportion, so it's a normal z-score. We're looking for a proportion that exceeds this right here. So we're going to do our normal z-score of z is equal to our data value minus our mean over our standard deviation. Go ahead and calculate that out. And we get 0.20. So we're going to go ahead and find that on our table. So I need to find the 0.2 left-hand column. I need to go to the O0 column because that's my second number here. And that gives me this here. Now, notice we are looking for what it says of exceeding. Remember, our table always tells us what's less. So we need to go 1 minus what we got from our table. And then that gives us our answer of C. So here, once again, we are given a percent. So that means a reverse z-score problem. So we're going to start off with our x equaling mu plus sigma times our standard deviation. And we need to then start out with table A. Now, we're looking for the top 5%. So that, remember, table A always tells you what's less than. So that means 95% is less than. So we need to find 0.95 in the middle of our table, or what is closest to that, and that's in between these two numbers here. And so we're going to get our z to be that 1.6. In this case, since it's exactly in between these two right here, I'm going to go exactly in between these two right here, and that's where I get the 4 or 5 from. So that's my z. Now I'll plug that into my formula here. And then we end up getting this right here, which you can see the one that is closest to it is B. Now, we're looking for a percent. Whenever you're looking for a percent, it's a normal z-score. But in this case, we're going to look for a percent in between. So we need to do a z-score for our 490, and we need to do a z-score for our 590. Look those up in the back of our book in the middle of the table and subtract those numbers in the middle of the table. So we'll start out with our z being the 490 minus our mean over our standard deviation. And then we'll do the same thing for the green. And we'll go ahead and calculate each one of these and look each one up in our table. And we look for our negative 0.5 on the left-hand side. Go to the O5 column, and we get this right here, and we're going to write that down. Then we're going to do the same thing for the green one. And we look for our 0.7 on the left-hand side. Next one over is the O5, so we're going to go to there. And we'll write that one down. Now, remember, we're looking for what's in between. We need to go ahead and subtract these two numbers. Remember, we're looking for a percent. It has to be positive, so we've got to take the larger minus the smaller. When we subtract those two, we get a 0.4649. But since we are looking for a percent, we got to move that decimal point over 2 spots, so we get 46.49%. So we get answer A. Here we are looking for a percent, so that means it's a forward normal z-score. We're looking for less than, and that's what our table tells us, so it's just a normal z-score problem. So we'll go z is equal to our data value minus our mean over our standard deviation. And we'll work that out and look it up on our table. To the nearest 2 decimal points, it's a negative 0.90. Now that's what we need to look up on our table. So I'll pull up my table here. And so we get from our table 0.1841. But notice it said percent here, so that means it's going to be answer B. We have 2 situations going on here. We have young women. For the young women, we have a standard deviation of 39 with a mean of a 185. And we have Sandy, our young woman, with the 220. Now we also need to look at the men. Her father has this cholesterol, but for men, the mean is this here, and the standard deviation is here. We really need to go ahead and figure out the z-score for each one. Remember, your z-score is how many standard deviations you are above or below the mean. So whoever has the higher z-score has the higher cholesterol for their age group. So we'll start off with Sandy. So we'll go the 220 minus the 185 over our standard deviation of 39. Then we'll also go ahead and do her father of a 250 minus the 222 over the standard deviation. We'll figure out each one of these. So we get Sandy. When we go to the nearest 2 decimal points being this, we get her father to be this. So Sandy has a higher z-score, higher number of standard deviations. She is above or below the mean. So who has the higher cholesterol? It is Sandy.